This is independent and dependent coming from student handout 5 and student handout 6. Student handout 5 talks about independent first, so we'll go into that. First, we're going to review a little bit of multiplying fractions, simple stuff here. How do we multiply fractions?
Top times top, bottom times bottom.
All right, 1 times 3 gives me 3. 2 times 4 gives me
8.
Can that be simplified? No, so that's my final answer. Here, 1 times 4 is 4. 8 times 5 is 40. Can that simplify? 1/10. 2 times 3 gives me 6. 4 times 5 gives me 45. Can that simplify?
9 times
By 3. 6 divided by 3 is 2. 45 divided by 3 is 15. Okay, so this is going to help us with today's probability. When the outcome of one event does not impact the outcome of the second event, the event is called independent. Independent probability can be determined by multiplying the probability of each event happening, or probability of A and B, where we first take the probability of A and multiply it by the probability of B. Alright, so that sounds like a bunch of foreign language almost, right?
Yes.
Okay, so let me explain it to you in Miss Adams' fabulous, wonderful ways that she does. So, independent probability. If I had 30 students in this classroom and I put all your names on a piece of paper and put it into a bucket to draw your name, how many names are in the bucket? 30. I pick up a name and I pick up Kale's name. I have Kale's name in my hand. How many names are in my bucket? 29. Because Kale's name is in my hand. What independent variable says, if I'm picking a first place and a second place, I drew Kale's name, he got first place. Then if I draw again, independent means I'm putting that name back in the drawing to draw my second place. So could Kale get both places? He could. Independent, I'm not changing the total names in my bucket. If I didn't want Kale to get drawn twice, I would have left his name out, right? And I changed the total number of names in my bucket. So it's no longer independent. I changed something about it. That is what independent means. So, let's look at some examples. It says in a board game, students draw a card, replace it, keyword there, and then draw a second card. Determine the probability of each. Alright, looking at number 1, it says to earn 50 points, a student must draw a heart-eyed card and then an angel card. So I'm going to look at heart-eyed first. How many cards have heart eyes?
2 out of 8.
2 out of 8. That's my first probability.
Would you simplify it?
You can, or you can leave it as that and simplify your final answer. Because aren't fractions equivalent if they're simplified?
Yeah.
So you can use any form of them. You're going to get the same answer. Okay, I replaced that card that I drew. So are there still 8 in my next draw? Yes. How many angels could be drawn? 1 out of 8, because I put the card back. Now to find the total probability of both things happening, we just multiply our fractions. 2 times 1 gives me 2. 8 times 8 gives me 64. Can that simplify? To 1/32. So that is my probability of drawing a heart, then an angel card. All right, let's look at number 2. It says to earn 20 points, a student must draw a sleepy card, then an angry. So what is the probability of drawing a sleepy? 2 out of 8. Okay, I'm putting that card that I drew back in the stack. Now what is the probability of drawing angry?
1 out of 8. 2 out of 8.
2 out of 8. So now I can multiply that. 2 times 2 is 4. 8 times 8, 64. Can that simplify?
Yes. 1/16.
1/16 is my probability. 3. To earn 15 points, a student must draw an angry card or laughy, so those go together, and then an angel. So how many are angry or laughy? 3 out of 8. And how many are angels?
1 out of 8.
Yep, it's very rare. Yeah, Audrey. Such an angel. I multiply this. I get 3 over 64. Can that simplify?
No.
No, so that is my final answer. And 4, to earn 5 points, students must draw a sleepy or a heart, so those go together, or then an angry. So sleepy or heart, how many totals does that get?
3 out of 8.
How many? 1, 2, 3, 4 out of 8. And angry is 2 out of 8. 2 times 4, 8. 8 times 8, 64. Can that simplify?
Yes.
To 1/8, and that would be my probability. And that's all I'm doing on independent variable. That's pretty easy. So now I'm looking at student handout 6, dependent variable or events. And the definition for that says when the outcome of one event impacts the outcome of another, it is a dependent event. So let me explain what that really means. So my scenario a second ago, 30 names in a basket. I picked one and it was kale. Dependent says you don't put the name back in the bucket. So for the first probability, I had a total of how many names in the bucket? 30. But if I pick Kale's name up, am I putting it back?
No.
So how many names is going to be in the bucket for my next probability? 29. Okay? So I'm changing the event because I'm changing the number of names in the bucket. So it's no longer independent. Can you change independent people's minds? No. That's why they're independent. All right, so we're going to read through these scenarios and determine if they're independent or dependent. It says flipping 2 coins results in one landing on heads and one landing on tails. Well, when I am the football game, they'll flip a coin. And someone will either holler heads or tails, right? By them hollering the name, is that going to affect what the coin lands on? No. The coin is going to land on whatever it's going to land on. We can't change that. So is the coins flipping going to be independent or dependent? Independent. We can't change it. The captain of the football team is selected, and then the co-captain is selected. Okay, well, can the captain and the co-captain be the same person? No. So, would that be independent or dependent? Dependent. Dependent. I'm changing the number of people I can pick from. You draw a joker from a deck of cards, and then you draw an ace. Am I putting that card back?
No.
So is that independent or dependent?
Dependent.
Dependent because I am changing the total number of cards. You draw a queen from the deck, replace it, and then draw a 10.
Independent. Independent.
Why is it independent? What key word?
Because you replace.
Replace it is key word. So that means I never changed the number of total cards that was in my deck. What?
What about, it says replace it, but then you said in drawing 10.
Okay, I picked Kale's name out of 30. I said, all right, Kale, you won. I put it back. How many am I drawing from? 30. I didn't change the total. I'm picking in another name. So I didn't change the total. If I kept Kale's name out, I changed it to 29.
Which makes it dependent.
Yes. A coin is flipped and a number cubed is rolled. Independent. We can't change what it lands on. There are rigged devices. We're assuming these are fair. All right, so let's try some dependent examples. To remember, we did the probability of the first event, A, times the probability of the second event, B, is how we found our probability on student handout 5. Dependent starts out the same. You're still going to find the probability of A. You're still going to multiply, but you're going to multiply a new probability after A has happened. Because was Kale's name still in the basket? No. If I left it out, his name's no longer in the basket. So that's a new whole set of probability. Case 6. Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? So I start off the same. Well, what is the probability of a bone?
3 out of 7.
3 out of 7. That's the same. Okay, I have the bone in my hand. I'm purchasing the bone. So is it in the basket?
Yeah.
No, it's one bone is no longer in the basket. Okay, how many items do I have now?
4.
6. How many are balls?
2.
2 out of 6 is my new probability after the first event has occurred. Because I used up a bone. It's in my hand. Now I can multiply this. 2 times 3 gives me 6. 7 times 6 gives me 42. Can that simplify? 2, 1, 7. So my probability of both of those two things happening is 1/7. 7. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? Well, what's the normal polka dot candle probability right now? 2 out of 5. Okay. Well, I have one polka dot candle in my hand right now, so it's no longer in the basket. Now what's my probability of getting a polka dot? 1 out of 4. Multiply that, I get 2 out of 20, which gives me 1 out of 10. So I have a laundry basket here full of these items, and I'm about to find the probability. It says, what is the probability of selecting a top and then selecting a bottom? Well, how many total items do we see? 16. How many total items is a top? 1. A shirt.
Oh, I thought you like the top of it.
Okay. Did I put the item back? Did it say I replaced it?
No.
So how many items after I picked up the shirt is there?
15.
15. Now I'm looking for bottoms. Bottoms include the pants and the skirt. So how many items is that?
4 out of 15.
5.
5.
So I have 1 times 5 is 5. 16 times 15 is 240. Can that simplify?
Yes.
To 148.
Is that a blanket or a towel?
Towel.
Oh, it'll be a blanket.
Oh, yeah, it says towel.
Okay, so probability is 148. Yes.
So basically, if you had to keep going down, like, would you cross off the shirt because the shirt wouldn't be in it, like as we do the next problem?
No.
Or you keep
If they asked me more stuff with this problem, I would keep going down. But the whole new problem, I'm starting with the original stack. Okay, number 9. What is the probability of selecting a striped sock, replacing it, and selecting another striped sock? What's a key word here?
Replacing.
So both times, how many total items am I looking at? 16. Okay, so I'm looking for first a striped sock. How many can I choose from?
No. 5.
5. I picked it up and I put it back. So how many striped socks are in there?
16.
Striped socks?
Oh.
5 out of total 16. Well, what's 5 times 5? 16 times 16, 256. Can this simplify?
No.
The only thing it could divide by is 5. I don't think it can.
There's no way that can divide by 5.
No way this can. So that is my probability of that happening. I think we are getting the idea.
Yes, definitely.
So you have homework 5 and 6. When is it being checked? Tuesday. You have a test Tuesday. You have plenty of time to knock out most all your homework right now.
Understand.